This is question number 12, problem 11-13 of homework 1 for chapter 11. Consider the following information on stocks 1 and 2. So we're provided with the different economy states. We have basically 3 economy states: recession, normal, irrational exuberance. And under each economy state, we have a probability. We have the individual returns, the returns under each state for stock 1 and stock 2. And the market risk premium is 8%, and risk-free rate is 6%. So the rounding requirement: do not round the intermediate calculations until your standard deviation answers as a percent rounded to 2 decimal places, and round your beta answers to 2 decimal places. So we have to be very careful about the rounding requirement here. The question is asking about the standard deviation on stock 1's expected return is, and the stock 1 beta is, the standard deviation on stock 2's expected return is, and the stock 2 beta is. Therefore, which stock is riskier? So first we'll try to figure out what is the standard deviation. So this is a very standard question about that calculation. We can have multiple tools to help us to solve this problem. We can use a scientific calculator. We can use a financial calculator. Here I prefer to use, I choose to use Excel because one of the advantages of using Excel is that it automatically meets this rounding requirement of do not round intermediate calculations. Economy state: recession, normal, irrational exuberance. Irrational exuberance. The probability. So recession happens with 20% chance, and normal state happens with 0.55% chance, and irrational exuberance happens with 25% chance. So stock 1 return under recession is 5%, and under normal is 20%, and under irrational exuberance is this is kind of weird, right? It's this may be a it's not a normal stock, right? Because normally we would imagine that the return will go up when the economy states becomes more booming, but here actually it's not the case. But let's just copy down the numbers. So that's stock 1. Stock 2, under recession, it's a negative number, and under the normal state it's 9%, and under irrational exuberance it's 42%. So this is basically the setup. We can first calculate the expected return. Expected return for expected return EI, and so expected return is the weighted average of the returns of individual assets within the portfolio, and the weight is the probability. The expected return for a single security is the weighted average of the returns under different economy states. And weight is the probability of a specific economy state. So here we have 3 economy states, and the probability for the first one recession is 20%, and that times the return for stock 1 under the economy on recession is 5%, and go on, plus the probability for the normal state times the return under normal state, plus the probability under irrational exuberance, and times the return under irrational exuberance. So that's the expected return for stock 1. The same will be the stock 2. So stock 2, the expected return will be the probability for the recession times the return under recession plus the probability of normal times the return under normal plus the probability of irrational exuberance times the return under irrational exuberance. So that's the expected return for stock 1. And given the expected return, now we can calculate the standard deviation. So standard deviation is the square root. If we go to my lecture slides, standard deviation is the square root of the weighted average of the squared deviation of the return from the expected return. And the weight is again the probability of different economy states. So that's basically what we did on the lecture slides. So given that, I'll go back. It's the weighted average. So we have a very, very big square SQRT. SQRT basically is taking the square root function itself. Now a number. So the number will be it's the weighted average. The weight is the probability. But now we need to multiply the squared deviation. So squared deviation of the return for stock 1 under recession minus so it's a deviation, so it's return under that economy state minus the expected return. And then we need to take the square of that and go on the probability under the second state times the squared deviation. So it's the return under the second state minus the expected return and square root plus the probability under the third state times the squared deviation, the return under the third state minus the expected return, and take the square root of that. So, and that gives me this number. So we have to go back to the rounding requirement. Enter your standard deviation answers as a percent, rounded to 2 decimal places. So we have to change this to be percent, a percentage, and rounded to 2 decimal places. So that's the first part of the answer. So for the second stock, sigma 2, the calculation is similar. So it's a big square root function, and then we take the probability times square root the return under recession minus the expected return, and take the square root of that, taking the and then square plus the probability under the normal times the square deviation, the return under normal minus the expected return, and square of that, taking the square, and the probability of the third state times square of the deviation. So it's the return under the third state minus the expected return for the third stock, for the second stock, and square of that. So again, we need to change the format to be percentage and 2 decimal places. So that's the first part, and we have calculated basically the standard deviation. But the question is also asking what is the beta for both stocks. So how can we figure out the beta? Here we figure out the expected return, and the question setup also provides us with the market risk premium and the risk-free rate. So if we go back to my lecture slides, we can find the camped asset price and model equation. The expected return of an individual asset equals the risk-free rate plus beta times the market risk premium. So market risk premium here is given, and the risk-free rate is also given, and the expected return we just calculated for stock 1 is 14%, is 0.14, and for stock 2 it's 0.1105. So we have done that calculation, and so based on this equation we can solve out this beta. So that's how we can do this question. But here I can also use Excel to figure out the answer. How can I use Excel to figure out the beta? So let me see, beta 1. So beta 1, let's assume an arbitrary number. Let's say this is 0.5. Obviously, this may not be the correct answer. Most likely it's not, because I just arbitrarily choose a number. But I want to use the, why don't I write down like this? So market risk premium, market risk premium. So this market risk premium is provided to be 8%, and risk-free rate, why don't I write down this to be RM minus RM. Sorry. Here. And risk-free rate is 6%. So now if beta is 0.5, then we can calculate this expected return for stock 1. So I call that E11. So E11 will be based on the campaign model here, will be RF plus beta times this risk-free market risk premium. So this is 10%, and 10% is not equal to 14% here, right? Because 14% is the actual number for the expected return. And this is expected because, as I said, this is just arbitrarily chosen. But I want to use a function within Excel to solve out the beta here, which makes this expected return for stock 1 to be exactly equal to this actual expected return. So I choose data, and then what if analysis, and then goal seek. So here I choose the D13, which is exactly this cell. I want to set cell to be equal to so here I have to make sure, before I do that, I have to make sure this is a precise number, because I want to comply with the do not run intermediate calculations. So E1 have to make sure format cell and keep the number Yeah, you can keep a lot of decimal places. Yes, this turns out to be a precise number, so no problem. So now I can use the go seek to be. So what's particular about the go seek is that you cannot set cell to be another cell value. Here you have to choose a specific numerical number. So have to use this 0.14. By changing cell, by changing this beta. Yeah, because I want to change this beta to make sure this expected return for stock 1 be exactly equal to this 14%. Okay, so beta turns out to be 1. And this is interesting, right? Because we know that market, the beta for the market as a whole has equals to 1. So that means the stock 1 actually here has the same systematic risk, because beta is a measure of the systematic risk. The same systematic risk as the market. So that's the beta for stock 1. And we can do similar things for stock 2, beta for stock 2. So I assume another whatever number, 0.7. Okay, obviously this may not be the precise value that I need, but we can use campaign to calculate the expected return if beta turns out to be this, to be 11.6%, and this is not equal to the actual value of expected return for stock 2, and that's expected. But if we use go seek, again, to be before I do that, I want to make sure try to keep as many decimal numbers as possible. Okay, it seems that 0.1105 is a precise number. Okay, so again, data and what if go seek, set cell F13, that's exactly the cell, to be equal to 0.1105. By changing cell, the beta for the second stock, oh, what happened here? Oh, I have to use this. Okay, so now go seek to be 0.5 and change this by changing the cell. So now you see once the beta for the second stock becomes this number, then the expected return will be precisely equal to what we need. So we have basically solved out this is what we need, and this is what we need, and this is what we need, and this is what we need. So here I just copy number, but note the rounding requirement again. Rounding beta answers to 2 decimal places. So 2 decimal places, I have to change the format here to 2 decimal places. So copy the number. The standard deviation on stock 1s is 6.71, and stock 1 beta is 1, and the standard deviation on stock 2's expected return is 21.45, and stock 2 beta is 0.63. So here, the final part of this question, which stock is riskier? We know that we have two different types of risks. One is the systematic, the other one is the unsystematic. But within these two types, the unsystematic risk will not give us a higher expected return. The reason is that we can simply diversify it away by investing in a portfolio of assets rather than just investing in that single asset. So the unsystematic risk does not matter for our return. Hence, only the systematic risk matters. So if we want to compare the riskiness of different assets, we simply look at their systematic risk. So in this case, which stock has a higher systematic risk? It's stock 1, right? Because it has a beta of 1, but stock 2 has a beta of only 0.63. So you can see that even though the standard deviation for stock 2 is higher, but stock 2 actually is the less risky asset because its systematic risk is lower. So stock 1 is riskier. Check my work. Okay, we got every number to be right.